Hello, future educators. In this lesson, you will learn the foundations of physical science. This comprehensive guide will cover the structure and properties of matter to the principles of motion and energy. By the end of this session, you'll be well prepared to tackle these topics on your teacher certification exam. Structure and properties of matter. Understanding the structure and properties of matter is fundamental in physical science. Let's break down some key concepts. Color. Remember, color is not an inherent property, but how substances interact with light. It's crucial for identifying substances and observing changes like temperature or chemical reactions. Mass. A measure of the amount of matter in an object, crucial because it's conserved in both physical and chemical changes. Density. Defined as mass per unit volume, density helps predict whether an object will float or sink in another substance. Hardness. Using the Mohs hardness scale, we can determine the resistance of a material to deformation, which is vital in material selection. Electrical and thermal conductivity. These properties define how well a material can conduct electricity or heat, influencing the use of materials in various applications like wiring and insulation. States of matter and changes in state. Matter exists in three primary states: solids, liquids, and gases, each with unique properties. Solids have a definite shape and volume, with tightly packed particles. Liquids have a definite volume but take the shape of their container. Gases have no fixed shape or volume, filling any container they're in. Changes in state, such as melting, freezing, and vaporization, are physical changes that affect matter's density and volume. Understanding these processes is key to explaining natural phenomena like the water cycle, and everyday processes like cooking. Energy and changes in state. Energy plays a crucial role in changes of state. Endothermic processes. These absorb energy, such as melting or evaporation. Exothermic processes. These release energy, like freezing or condensation. Understanding chemical changes. Chemical changes involve the transformation of substances into new ones, a process fundamental to chemistry. Indicators of chemical changes. These include color changes, temperature changes, gas formation, and more. Types of chemical reactions. From synthesis to decomposition and combustion, each type of reaction has distinct characteristics and outcomes. Principles of motion and energy. Motion and energy are cornerstones of physical science. Displacement and velocity. These vector quantities describe motion direction and magnitude. Acceleration. This is the rate of change of velocity, a key concept in understanding forces. Forces, understanding the push and pull, including gravity and magnetism, is essential for explaining motion. Mixtures and solutions. Mixtures. These can be homogeneous or heterogeneous, each with distinct properties. Solutions. A type of homogeneous mixture where one substance is dissolved in another, crucial in various scientific and industrial applications. Interactions and states of matter. Chemical bonds and intermolecular forces. These interactions determine the physical properties of compounds and their state changes. Phase changes. Learning about the energy involved in these changes helps explain many natural and technological processes. Optical properties of waves. Understanding how light interacts with different mediums is essential in physical science. Let's explore two fundamental phenomena. Reflection. This occurs when light bounces off a surface, such as a mirror, without altering its intrinsic properties but changing its direction. This principle is why you can see your reflection in a mirror. Refraction. This is the bending of light as it passes from one medium to another, changing speed and direction. A common example is the bending of light through a prism, which not only alters its path, but also disperses it into a spectrum of colors. Conservation of energy. Energy conservation is a principle that underpins much of physical science, particularly in discussions about renewable and non-renewable resources. Renewable resources. These include solar, wind, hydropower, biomass, and geothermal energy. They are sustainable and replenish naturally, making them crucial for long-term energy planning. Non-renewable resources. These are resources like fossil fuels and nuclear energy, which are finite and deplete with use. Understanding their impact on the environment and economy is essential for responsible usage. Conservation strategies. Strategies such as promoting energy efficiency, transitioning to renewable energy, and implementing supportive regulations are vital for sustainable development. Forces in motion. In physical science, understanding how different forces affect motion is crucial. Friction. This force opposes the motion of objects in contact. It plays a critical role in everyday activities, such as walking and driving, by preventing slipping and aiding in the stopping of vehicles. Inertia. Defined by Newton's first law of motion, Inertia is the tendency of an object to resist changes in its state of motion. The greater the mass of the object, the greater its inertia. Electrical and magnetic forces. These forces govern the attraction or repulsion between charged particles or magnetic poles. They are fundamental to the functioning of many devices, from electric motors to household appliances, forms of energy and their transformations. Energy can exist in various forms, all of which can transform from one type to another. Kinetic energy, energy due to motion. Anything that moves has kinetic energy, which can be transferred between objects or transformed into other energy forms. Thermal energy. This form of energy is associated with the temperature of an object and is transferred through heat. Chemical energy, stored in the bonds of chemical compounds and released or absorbed during chemical reactions. Potential energy, stored energy due to position, such as water held behind a dam or a stretched spring. Applying knowledge in instruction. As future educators, it's crucial to not only understand these concepts, but also to effectively convey them. Demonstrations and experiments. Use practical demonstrations to show energy transformations, such as converting potential energy into kinetic energy using a pendulum. Problem-solving exercises. Engage students with problems that require the application of the conservation of energy, enhancing their analytical skills. Discussion of real-world applications. Discuss how these principles apply to real-world scenarios, such as in power generation, vehicle design, and environmental conservation. Great! Now check your mastery level by taking the Physical Science Practice Test at teacherpreps.com and get full access to the test prep materials that make passing your teacher certification exam simple. Thank you for watching, and I'll see you in the next lesson.